Hello class. So today we're going to be talking about dilations, and we're just going to start out with dilating points today, and then tomorrow we'll get into shapes and figures. So starting with this first example, plot the image of point A under a dilation about point P with a scale factor of 3. Well, we know a dilation is either a stretch or a shrink of something. So we can start with looking at the distance from A to point P, our center of dilation. Well, how far away is A from point P? Well, to get from point P to point A, we go minus 1 units in the vertical direction because we're going down 1. And then we're going 1, 2 units to the left. So that's going to be minus 2 units in the horizontal direction. Now our scale factor is going to be 3, so we always want to multiply by our scale factor. So negative 1 times 3 is going to give us negative 3. Which is going to represent our vertical shift. And then negative 2 times 3 is going to give us negative 6, which represents our horizontal shift. So starting again at our center of dilation, point P, we're going to go 3 units down and 6 units to the left. 1, 2, 3, 1, 2, 3, 4, 5, 6. And we're going to call this A prime. And as you can see too, just visually, we're stretching that fact that the length of AP, segment AP, to a factor of 3, so it's 3 times as big. And you might be thinking, wait, I thought a dilation was an enlargement or reduction of some, like a certain size. A prime is the same size as point A, so how can that be? Well, you can imagine if there's a group of points surrounding point P, if we stretched all of those points by a factor of 3 away from point P, like say we had a triangle, and all angles or all vertices of the triangle were also scaled by a factor of 3, then the triangle would be much larger, and the center would have been point P. So if there was a collection of points and we did the same thing, and this represented just one angle of a shape, then we would have a stretch or an enlargement of that figure. So let's look at another example. Plot the image of point C under a dilation about the origin, 0, 0, with a scale factor of 1/5. All right. Well, if our center of dilation is the origin, how far away is point C from the origin? Well, we're going 1, minus 2, minus 3, minus 4, minus 5 units in the horizontal direction because we're going left 5. 1, 2, 3, 4, and then 5 units in the vertical direction because we're going up 5. Well, if we do 5, multiplying by our scale factor again, because we always want to multiply by that, we're just going to get 1, and that's going to represent our vertical shift. And then minus 5, which represent our horizontal shift, multiplied by 1/5, is just going to give us negative 1 in the horizontal direction. So if we're going, starting at our center of dilation, we're going 1 over and up 1. That will give us our new point of C prime, which will be at the point negative 1, 1. So let's try another example. Plot the image of point D under a dilation about the origin 0, 0 with a scale factor of 3. So we want to find out where is D prime located. So pause the video, take a couple minutes, try it out on your own, and see if you can get it. If not, I can go over how we got this. So we're going to be dilating about the origin with a scale factor of 3. We're going minus 2 in the horizontal direction, and then 0 in the vertical. So if we just do minus 2 times 3, we're going to get minus 6, and that represents the horizontal shift. So negative 2, negative 3, negative 4, negative 5, negative 6, and that's going to give us D prime. And because it was there's no change in the horizontal and the vertical shift, as the same y coordinate, will just 0 times 3 just remain 0. So it's going to be at -6, 0. Let's try another example. Plot the image of point A under a dilation about the origin 0, 0 with a scale factor of 1/3. So where would A prime be in this example? Now, if you're still confused by that, we can go over it together. We see that from the origin to point A, we're going to go -1, -2, 3, 4, 5, -6 units in the vertical direction, and then +3 in the horizontal direction. -6 times 1/3 is going to give us -2 in the vertical direction. And then 3 times 1/3 is just going to give us +1 in the horizontal direction. So again, starting at our center of dilation, the origin, we're just going to go across 1 and down 2 to give us A prime at 1, -2. All right. Plot the image of point D under a dilation about the point -1, -1 with a scale factor of 3. Well, in this case, we're going to have to draw in our center of dilation, so -1, -1, and our scale factor is going to be 3. Well, if we're going down 1 and then left 2, so -2 to get from our center to point D, we're going to want to go down 3 and left 6. Because -1 times 3, always multiplying by our scale factor, is -3. -2 times 3 is -6. So we can go -1, -2, -3, -1, -2, -3, -4, -5, -6. D prime. So D prime is going to be at -7, -4. Now for our last one, plot the image of point B under a dilation about the point -7, 3 with a scale factor of 1/2. So again, it might be useful to draw in our dilation point, and remember we're going to be solving for B prime. Take a few minutes, try that out on your own. If you're still confused by it, here we can try it together. So yeah, like I said, it might be helpful to draw in our dilation center. So -7, 1, 2, 3. It's going to be this point right here. Well, to get from this point to point B, we're going to go -1, -2. 1, 2, 3, 4, 5, 6, 7, 8. And then +8 in the horizontal direction. Well, -2 times 1/2 is just going to be -1. +8 times 1/2 is going to be +4. So we want to go down 1 and right 4 to get our point B prime. So down 1, right 4, so right 1, right 2, right 3, right 4. That's going to give us B prime at -3, 2.